65 distinguishing types of parallelograms. Yes, they like to have lessons on parallelograms. There are lots of different things about parallelograms, so they like to have a lot of lessons on them. Just like triangles, parallelograms have lots of properties that you had no clue about. So in case you have forgotten, parallelograms is a big group of things. And rectangles, rhombuses, and squares are all types of parallelograms. If you look, are all parallelograms rectangles? Are all parallelograms squares? Are all parallelograms rhombuses? So we could have a parallelogram that is not a rectangle, square, or rhombus. Okay? Are all squares rectangles? Yes. Are all rectangles squares? Okay. Are all squares rhombuses? But are all rhombuses squares? Okay, so you got to keep that in mind whenever you're looking at parallelograms. So let's look. A rhombus. Yeah. If it's if it just says it's a rhombus, it could end up being a square if it had right angles. And if it says it's a rectangle, it could end up being a square because the sides could all end up being equal. It's just like isosceles and equilateral. If you have an isosceles triangle, it could also be an equilateral triangle. So, looking at a property of parallelograms. If an angle in your parallelogram is a right angle, then the parallelogram is a rectangle. So if you have one right angle, then the parallelogram has to be a rectangle. How are these two angles related? They add up to 180, right? So if one of them is 90, what does that mean about the other? It has to be 90. What about these two angles? They have to equal 180. So if one of them is 90, the other has to be 90. And then what about these two angles? Same thing. They have to add up to 180. So if one's 90, the other has to be 90. And so that's how, if you have one right angle, they all four have to be right angle. Does that make sense? Right. Looking at another property of parallelograms. If we have consecutive sides that are congruent, then it has to be a rhombus. What do we know about opposite sides of a parallelogram? Yeah, they are parallel. What else? They're congruent. And so, if this side is congruent to that side, what do we know about these two sides? So this side has to be congruent to that side. So what just happened? They're all four congruent, so you have a rhombus. They told us the two next to each other were congruent, but we already know from properties of parallelograms that opposite sides are congruent. Okay, so that means that they all have to be congruent. All right, so is the parallelogram rhombus if x equals 7 and y equals 5? And then you have to explain your answer. So how many think it is a rhombus? How many think it is not a rhombus? How many still are working it? Okay, who wants to explain why they think it is a rhombus? Go for it, Destiny. She said the two that were next to each other were 26, so that means that all four of them have to be 26, which makes it a rhombus. Any questions here? Okay. Looking at another property of parallelograms. If the diagonals of a parallelogram are congruent, it has to be a rectangle. You already learned for all parallelograms that the diagonals bisect each other. But if the diagonals are congruent, it has to be a rectangle. So let's look at another example. They want us to figure out what value of n would make math a rectangle. Yes, those values are pointing to the diagonals. So what value of n makes math a rectangle? Right? What value would n have to be? 4.5? Do I need to go over that one? Okay. Another property of parallelogram. If the diagonals are perpendicular, then it's a rhombus. What other shape would have perpendicular diagonals? A square? What else? Would a rectangle have perpendicular diagonals? No. The kite? I think that's it. So, it wants you to figure out if this parallelogram is a rhombus. So, is ABCD a rhombus? So, what are you probably going to want to figure out? Why, if it's a right triangle? You'd have to have a right angle to make the diagonals perpendicular. So figure out if it is a rhombus. Alright, what do y'all think? Yes? Because that's the right angle, which makes the diagonals perpendicular. Because using Pythagorean theorem, that has to be a right triangle. Because 21 squared plus 28 squared equals 35 squared. No. Yeah. Any questions here? Okay. Looking at another property. This is the last property for today. If a diagonal bisects opposite angles, it has to be a rhombus. What kind of angles are these two angles? Alternate interiors. What about these two? And what do we know about alternate interiors? They're congruent, and it can be shown that the red and the green are actually congruent to each other as well. And so if you have a diagonal that splits your opposite angles in half, then it has to be a rhombus. So see if you can use that to figure out or prove that WXYZ is a rhombus. So it's telling you it is a rhombus. Now you have to show how you would prove that. So it's not saying, is it a rhombus? It's not a yes or a no. It's a, it is a rhombus. Tell how you know that. Well, for a rhombus, yeah. Rhombus is always bisect opposite angles, but not for a rectangle. Like, well, do you see how this? Do you see how they do wrong? Like these two angles here and here. But for a rectangle, it's not going to always bisect. Now for a square, it would. But a square is also a rhombus. Who wants to explain how we know it is a rhombus? Okay. How do you know x is 30 degrees? Okay, so opposite sides have to be equal to each other, so then you solve for x equals 30. Okay, so that makes the diagonal bisect that angle. So that makes it a rhombus. Yeah. Does that make sense? All right. Looking at another example, a carpenter is building a gate 48 inches tall and 55 inches wide. How long must the diagonal brace be to ensure that the gate is rectangular? All right. How long does your diagonal brace have to be? 73? Using Pythagorean theorem? Does that make sense? Okay. So see if you can figure out whether that top parallelogram is a rectangle. Those are the angles. All right. Rectangle or no? Okay. See if you can figure out whether the bottom one is a rhombus. All right, what do y'all think? Why not? You don't get 81 over 5 whenever you solve for x. You get x equals 2.4. Yeah. And then if you plug that back in, it's not equal to 81 over 5. And they all have to be the same for it to be a rhombus. Yeah. Does that make sense? Okay. Looking at a top one, is it a rectangle? Well, what do you get for your x first off? 8. So is it a rectangle? Okay. Looking at the bottom one, is the parallelogram a rhombus? Is it a rhombus? Why not? Yeah, the angle doesn't equal 90 degrees. You got x equals 18? So 13? I got x equals 18. And then x equals 18. And this angle is 85. And this one is 95. That would work too. Either way. Because if you plugged it back in, what would you get? So that obviously doesn't work. Either way it'd work. The way that y'all did though, yeah, but that you don't know that they're equal. You just assume they were. Yeah. Yeah, but if it said what is x equal, if you had put 13, that wouldn't work. Like it worked to show you that they weren't equal to 90, but since it's a line, they do have to add up to 180. Does that make sense? Okay. All right, let's look at another couple. I want you to figure out if the parallelogram is a rhombus. Is it a rhombus? What'd you get for X? Okay. Any questions on that one? All right, last one. A sign in the shape of a parallelogram has diagonals that create an equilateral triangle as shown. Is the sign a perfect rectangle? And explain how you know. So explain how you know. Okay. Okay, all parallelograms bisect each other, so that means that that's true. Okay. Now what? So one diagonal is congruent to the other, so what does that mean? This diagonal is equal to that diagonal, right? Because they have to add up to the same. So what does that mean? It's a rectangle, because the diagonals are equal. Yeah. I have no idea why it has to be, why they call it a perfect rectangle. Because in their explanation it says, blah, 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 the diagonals of the sides are, or of the sign are congruent, and it is a rectangle.
Put that on just blah, 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 blah.
No, I mean, we just like said it, so. Alright, so this is a challenge question. We want to draw a rectangle on a coordinate plane with opposite vertices at 0, 0, and 2a, 2b. And prove that it is, or the quadrilateral formed by connecting the midpoints is a rhombus. So there's one. Where does the other one go? We're going to go over 2a, and we're going to go up 2b. So do you see our shape? Okay, so prove that the quadrilateral formed by connecting the midpoints is a rhombus. So what do we need to do first? Okay, well, what would be the midpoint on this side? What is that? Okay. What is the midpoint on this side? What is the midpoint here? Okay, what is the midpoint there? So how would we show that it is a rhombus? We don't know that it makes a square. Because we don't know that it would only be a square if A and B were the same value. Do what? What about the sides? Yeah, it is a rectangle. So the sides of the black figure are parallel. But how are we going to show that it's a rhombus? That the, what? No, not the diagonals are the same. All the sides are equal? Okay. How would we show the lengths of those? Yeah, you would use Pythagorean theorem. Okay, so let's do this one. What's the length here? What's the length here? So what is going to be the length of the hypotenuse? And then the square root of that? Okay, what about for this triangle? What's the length here? What's the length here? What's going to be the length of the hypotenuse? Okay, let's do another one. What's the length of this side here? And here? What's the length of the hypotenuse? Okay, hopefully you're seeing a pattern and can say what the length of that is. The square root of a squared plus b squared. Since this length is a and that length is b. So is it a rhombus? Yeah, if you use slope. But it could have been a, yeah, that'd work. All right, so what is your homework? What problem set? When is it due?
Thursday.
Why not on Wednesday? Okay, good.